This is the first chapter in the Routing Protocols and Concepts course, Introduction to Routing and Packet Forwarding. In this chapter, you will learn about the router as a specialized computer, begin basic router configuration, learn how to read routing tables, and how routers use metrics to determine the best path to a destination network. This demonstration uses a product called Visual Route Server 2008, and it's available as a free download. So I suggest that if you have a chance that you do that, because it's a really interesting way to really see everything that you're going to be learning in this upcoming course. So what I'm going to do is right here, we're tracing from my computer, and I happen to be in Indiana, which is in the middle of the United States. And I want to see what happens if I send a trace request to a company that I know is headquartered in Denmark, so I'm hoping their web server is actually there. And it looks like it actually is, because if you look down here, you'll see that we have ultimately hit something in Copenhagen, Denmark, so that's good. Now we're still collecting data, and what you're going to see as you look at all this information is that it's sending multiple packets, so we can get an average time and then the full length of time. And each of these hops, if you want to, you can get more information about that particular router in the path. It has the IP address of the router, it tells you who owns the router, and something about packet loss. So as you see, it took 22 hops, or 22 touches, to routers on the path from my home in Indiana to a server in Denmark. And I'm going to close this up a little bit because I want to show you the route table that is available for us to look at here. So here you see each of the hops. It tells you a little bit about packet loss across some of these routers. Now we don't have information about why the loss is happening, but as you see, out of 22 hops, only 3 of them had issues, which I think is kind of amazing, really. The IP addresses associated with each of the routers, the node name, and that was the same thing that's in the route graph that we saw a few minutes ago. And here's an interesting thing. Here's the location. Now I'm in the middle of the United States, and yet the packets went first to the east coast of the United States in New Jersey, then came back a little bit west to Tennessee, then went further east again and south to Georgia, but then it came way back west to Colorado, which is further west than I am. Then it went east again to New York, and then finally went to Denmark and ultimately ended up in Copenhagen. So it's kind of interesting to think about, why would a packet take such a circuitous route rather than just going straight east to Denmark? Well, one of the things that routers do is try to figure out what is the best path to a place. And often the best path may not be the exact straightforward path. It may have to do with the bandwidth available on a particular link. So each router had to decide where's the best place to send this packet. And although it didn't come in any kind of straight route from my computer to Denmark, it certainly did get there rather rapidly. And if you look here, you will see that the average time it took was 138 milliseconds, and the most it took was 157 milliseconds from my computer to Denmark. So I think that's rather amazing. So realize, as you look at each of these nodes on the network, each of them is a router, which is just a specialized computer whose job it is to take in packets, look at the information about where the packet is destined to go, and to say, do I know how to send this packet towards its destination network? And if so, how do I switch that so it heads in the correct direction? So that's what each of these routers does as it receives a packet. The other thing you need to remember is that each of these routers was configured and is managed by a network engineer. So the reason that all these routers are working is because somebody told them to and made them work in an optimal fashion, and that's exactly what you're going to be learning. So I hope this was helpful. Do have fun in your class. I think you're really going to have an enjoyable time, and good luck as you move forward.